So, hello guys, welcome back to Gettobyte YouTube channel once again. I hope you are doing well and working good. So, this is the fourth video in continuation of starting with the S32 Design Studio IDE for a microcontroller technology learning tutorial series based on NXP S32K144 MCU using the ElecronicsV2 development board. So, in the last couple of three videos, we have get to know about IDE, which IDE to use. IDE is the first thing that we should enable when you're using the microcontroller. So we have done the software installation part, and we have made the project on understood how to make projects on this IDE for the microcontroller. And in the third video, last video, we have get to know about the code configuration tool, which is a kind of a tool used for microcontroller coding, in which without doing any coding we can initialize and do the basic initialization and basic configuration part of the microcontroller. So in the last video we have just get to know that how to open the code configuration tool for NXP S32 microcontrollers using S32 Design Studio IDE, how to use it and how to and thus understanding various different icons of this code configuration tool. Also, on the same thing, I have written a blog. Told you about that. I have written a blog on getting to know how to use the code configuration tool of the Design Studio IDE. Now, in this video, we are going to understand about the different tools which are there in the code configuration tool, which we can use for different peripherals, different features of the microcontroller. Like there is a pins tool, clocks tool, peripheral tool. There are different quad SPI, IVT, DCD tools, and these are the different tools. So I'm just going to tell you which tool is used for what purpose and how to use them. Okay, so yes, now without wasting time, let's get started. So now guys, this is our project, and let's just first, like in the last video we have get to know about the different icons that are there in the code configuration toolbar. So we have understood this line. Okay, so what are different these icons means and what are their significance and how to use them. Now in this video we are going to understand about different tools which are there in the code configuration tool. Okay, so there are broadly 5 to 6 type of different tools. First is the pins tool, another is the clocks tool, next is peripherals tool, another is DCD, IVT, quad SPI, and DDR memory tool. So each tool is used for configuring certain features, certain peripherals, certain specifications of the S32 microcontrollers. Now S32 is a broad family of microcontrollers of NXP that are concentric for automotive applications. Now in the studio design studio, all these tools are being developed and being shown over here, concerning all covering all the kind of microcontrollers of S32. But we are using S32K144 microcontroller. So it can be that there are certain features are there only in some microcontrollers. So correspondingly, only those tools will be enabled on those microcontrollers for those microcontrollers. So as we are using S32K144 microcontroller, so in it we will be only using pins tool, clocks tool, and peripherals tool. And you will see that these three tools are basic one and would be used in every microcontroller, whether of S32 or in general for in any tool. These tools would be the of any microcontroller. And these quad SPI, DCD, IVT, and DDR, these are the some high end and features that are there in the microcontrollers, but we are using the general purpose microcontroller. So in that these features are not there. So we'll be only concerning on the pins tool, clock tools, and peripheral tools right now for our understanding and for getting started. Now starting with the pins tool at first. So clicking on the pins icon over in here where my mouse is, you will be able to see the certain views that will pop up in your window. So first view that would be opened is the pins view, which is this one. Another is the package view, over which you can see your microcontroller properly and all the pins of the microcontroller. Another one is the important view is the routing details view. So in the pins tool, there are mainly three these views that would be are used and are important. So in the pins view, okay, as you can see over here, all the pins of the microcontroller you can see, and what are their additional features that we can configure them. So over here you can see the pin name, pin number, and the pin name. So in the corresponding microcontroller which we have selected right now, there are 100 pins, and each pin has been given a certain name: PTC 12, PTC 13, 16, 14, PTD 8, 9, or whatsoever. So PT stands for port, and the corresponding alphabet on over here stands for the port name at which that pin belongs. So this belongs to port D, this belongs to port B, this belongs to port E, as their name is PTE, PTD, or PTB. Then correspondingly we can manually write the label or identifiers for their configuration for their ease of use. And over here you can see all the peripheral names of the peripheral names. So port peripheral belongs to GPIO peripheral, FTM, LP, SPI, ADC, LPUART, and you can see that which pin has can be used for which peripheral. So each pin can be configured for number of features, number of peripherals. So we can do that via the pins view of the pins tool. So clicking on any tool, okay, any pin over here, it will pop up and will ask you that for which feature do you want to configure that pin. You can then select it, and then correspondingly more pop-ups will come according to what peripheral or what feature you are using. Okay. Another one which I have told you is of the that are good important one is the package view. So in the package view, you can see all the details of all the pinout of basically of a microcontroller, and over here you can switch the package. So like the S32K144 microcontroller we are using. So which package of that we are using? If you're using 100 package, or you're using 48 package or 64 package, correspondingly your pins would be used. It would be changed. Let's say I have used 64 package. Okay, so you will be able to now see it might take some time. Your package is changed, and also in the pins view you will be able to here now see your number of pins have been reduced to 64 in the pins view. So that is what also that all these configurations you can do from the packaging configuration and which you are using. So I am using 100 package right now, so that is what we will be using over here. Another view that is important in the pins tool is the routing details view. Over here, you can see the summary. Basically, it's a summary of whatever configurations that you have done in the pins view. So all the ports, pins, and what configuration you have made them. Okay, their direction is output or input. Their interrupt status is active or not active. Their interrupt configuration has been done or not done. Lock is done or lock configuration is done or not done. Pull up or pull downs are not done. So it's basically a summary, and you can directly change over here also. Let's say I want to enable some interrupt, so I can configure over here. I want to change the interrupt status. I want to lock certain ports that pins that I have done over the pins view. So these are all the main tools views in the pins tool. Another one also important is the register view. So in the register views, basically we can see the registers that are changed when we have configured the corresponding microcontroller pins. So if we click on show modified registers only, so we have configured port D and port C pins. Okay, so their values have been changed correspondingly. Okay, and another one is the peripheral signal view, over which you can see okay what all peripherals pins we have enabled or disabled. So we have enabled or we have configured. So we have configured for the port C and port D, as this is the hello world example which from which I am telling you. And there are icons over here show only analog digital signals, the pins or those things. So that's all the things in the pins view. So you can see that via the pins tool we can configure any micro pin of the microcontroller according to our need, to our application need for the features and the peripherals. So yes, so now let's move to the next tool, that is the clock tool. So now coming to the clock tool, the next tool that is in the configuration tools. So the clock tool is used to configure the clock of our corresponding S32 microcontroller. And so is to use this tool, one should be first of all aware about the clock module and the clock configuration of a microcontroller. That's just a general theory of the microcontroller in the clock sense. So the S32K144 is the microcontroller that we are going to use. So viewers can refer to the blog, or also can check out the video of the clock peripheral that I have made on this microcontroller, or they can also refer to the reference manual so as to get to know about the general trivia and understanding of the clock configurations in the clock module. So in the clock module tool, there are mainly these five tools that would be used mainly. Out of all these five, the clock diagram is the one that is most important and that would be used very much. So as you can see in the clock diagram view, you can see there is a basically kind of like a tree structure. GUI based tree structure has been made, and via which you can, there are number of boxes and number of configurations we can do over here. So as to configure the clock of a microcontroller. So there, this is the system clock generator block. Okay, and from first of all we configure the system clock generator. Okay, and then we get these output clock frequencies, and then these clock frequencies is being input to our peripheral clock module. This is whole is the peripheral clock. There are number of different peripherals and their clock sources we can configure. Then the next view is the details view. In the details view, we can basically see that what all configuration we have done in the clock diagram. So what is the system clock oscillator we have configured, what is the FIRC values, and what are the different buses, and basically the summary of all the clock diagram that we have done. So if you will see out of these five views in the clock diagram, the main configurations that we do is in the only clock diagram, and rest of the four views, clock table view and the clock consumer view, peripheral clock view, basically we get the summary and the information. Like in the clock table view, so clicking on the peripheral and the clock, so we can just see, you can see over here, okay, the EDC clock has been derived right now from the slow IRC, and its slow IRC is driving also SIRC clock one and these things. So basically a GUI based so as to know information like the port A. So port A is being right now being it is being derived from the SOSC, external crystal oscillator clock. Okay, let's say now we click on other sources, so you can see the, we can get to know about which peripheral clock is being driving by the which clock source. Okay, and in same way in the clock consumer we can get information about the buses of the clock. So like let's say the peripherals, about the peripherals, there is a SPI, I2C, UART. So which peripheral is being fed via the which bus, which and that bus is being configured for what frequency. So all that information we can get from the clock consumer. And same way in the peripheral clock view, more information, and in a different way we can get to know about the peripheral clock frequencies. So that's all about the clock tool. The important one and the most used one that will be used is the clock diagram. And the more hands-on on these things and how to use and those things we tell, would be doing those in the upcoming videos. Now let's move to the next tool, that is the peripheral tool. So this is the peripheral tool. Clicking on the third icon over here, the peripheral, you will be able to see such a window. Now over here, the component view is the one of the most important one in the peripheral tool. Over here, you can see there are different basically sections by the name of drivers, PAL, OS, libraries, middleware, and basically these are all the like let's say peripherals. So on the peripherals, there are different drivers. For the each peripheral, there are driver files, lower level files. So clicking on the plus sign, it will show you, or you just click on this all, and all the peripherals configuration we can do. So let's say we just click on any, let's say we click on LPUART. Okay. So if we click on LPUART, so corresponding GUI would be opened in the adjacent video. Okay, let's like this. Okay, so we can configure the peripheral LPUART according to the LPUART specifications and features. Let's say we need to add more peripherals, so let's just click on the plus icon, select that peripheral. Let's say we are doing for the ADC, click on it, and corresponding window will be open for the ADC, and it will be showing you the options and feature names according to the ADC peripheral features and specifications. So using the clock peripheral, the peripheral tool, we just need to first of all have an understanding about the corresponding peripheral that we need to configure, and that corresponding peripheral understanding according to the microcontroller that you are using. Coming to the next section is the PAL section. This is basically the kind of driver section only, but in the driver we would be configuring the lower level files. In the PAL we will be configuring the hardware section files, peripheral section files. So let's say we done for the UART only. So UART PAL if we configure, so corresponding LP UART PAL window will open. Okay, so now we'll be configuring the features of the hardware section layer of the LP UART. So this is kind of like configuring the hardware of the corresponding peripheral, and this is like configuring the corresponding software for using that peripheral. Okay, coming to the OS, like the operating system, real-time operating system. So FreeRTOS support is there for the K144 microcontroller, so we can configure that selected, and the corresponding window will be open in which you can configure all the FreeRTOS configurations and those things. Same way, there are certain libraries, built-in libraries for using the that can be used on K144 microcontroller, that we can select, and then that can be configured, and their corresponding window will also be open, and then we can do its configuration. And same way for the middlewares also. So like, just to tell you about the this thing, so there the peripheral tool, there are number of sections, five sections basically: driver, PAL, OS, libraries, and middleware. Out of these things, the mainly that we'll be using is the driver section, PAL section, and the OS section. OS section will also be used afterwards when we will be done with the all the peripheral programming and enablement. Then we will start with the free RTOS. Okay, and another thing is, before using the peripheral tool, we the whatever driver we are configuring, whatever peripheral we are configuring, or whatever library, middleware, or OS we are using, we first need to have some basic understanding and trivia about that thing. Then only we'll be able to understand, okay, what is this GUI mean, what are the things, what are the specifications we can configure, and those things. Okay, so that's all about the peripheral tool. Another thing about that is important in the peripheral tool is the code preview tool. So whatever configuration that you will be doing over here, corresponding files would be generated, and we can see those files that would are generated in the code preview section. Okay, so you can see there are number of like whatever configurations and whatever peripherals we have enabled, so corresponding files are being generated, and these files would be used in our code, application code, for corresponding configurations. Okay, so yes, so that's all about the peripheral tool. Okay, so you can see in the peripheral when you click in, so there are certain red sections showing, so it means there are certain configurations you have either done wrong or you have not done correctly. Okay, so we can get to know about that from the error view and the over here. So these are the only three tools that would be mainly concerning and that will be mainly using for our S32K144 microcontroller. That is pins, clock, and peripheral tool. And we will be exploring and doing hands-on and seeing how to configure each peripheral of the microcontroller and understand this GUI as we move forward with the microcontroller and do the peripherals of the microcontroller. So that's it in this video. I hope you get an idea that how to use the code configuration tool and how our code is being generated and what our code is generated as and when we do the code configurations. Okay, now in the next video, what we are going to do, we are going to understand how to, like, we have first of all created the project, we have then understood how to configure and how to develop the code for a project. Now we are going to understand how to build this project into L file that can be embedded, flashed to our microcontroller, and then how to debug and flash that L file into our microcontroller. Okay, so that we'll be covering in the next video. Till then, stay safe, stay happy. For any views, for any doubts, mention them in the below comment section, and do subscribe to the channel and share this video and this playlist as with your friends and so with your friends. So that's it for now guys. Like the video and subscribe to the channel, and do share it among your friends and press the bell icon to get notified with such videos as and when they are uploaded.